So far we've only used the very basic features of SOLIDWORKS Standard to do the evaluation and optimization of that bottle for the volume. You obviously have the same capabilities in SOLIDWORKS Professional, but as you get up to SOLIDWORKS Premium, where you have some simulation tool sets available, you can include that simulation data now as you run your sensors. So it works with motion, it works with thermal, it works with natural frequencies. All sorts of different things can be evaluated. So one example is a bike frame. You see here we want to actually simulate several different scenarios here for our bike frame. Different materials, different loading conditions, maybe even different types of bicyclists. So that could be done with a design study with SOLIDWORKS Premium. So let's open up that file. This one actually takes a little while to run, so I've run this one ahead of time, but I'll run some other ones live for you. So you can see I have the different tabs here at the bottom of the screen here. So I've set up a stress analysis, and the way we've set up this is a weldment in SOLIDWORKS with some surface bodies as well, just of the frame, and we didn't model the bicyclist, we didn't model the handlebar, the pedals or anything like that. We're just interested in optimizing the frame because we're purchasing those other components. We don't really have control of them. So we even gone ahead and set up our analysis. It understood the welded members and the surface bodies automatically because the simulation picks up on that. We've set up restraints on the back forks here for the bike rear wheel here, just so they're not going to move off of these hooks that you see right here. We've also set up a shock on the front of the bike. So you can see here we have this surface at the bottom. I have it selected. And I have an elastic connector as a fixture. So you can set an elastic support in SOLIDWORKS, and you can tell it what the stiffness values are in one direction and the other, the shear and the normal. So that's what I've done there. Then I've set up my external loads, and we've actually set up the loads so they're coming remotely into the model. You can see the where it's actually showing where the pedals and the handlebars are going to be touching the bicyclist. So those are set up using a remote load. If I edit the definition of the this first handlebar on the left, you'll notice there's a direct load transfer using a remote load command manager. You need to put a coordinate system in to reference it from. So as long as you have a coordinate system, here's my handlebars right in the middle. I'm going negative 469 in one direction and positive in the other direction for the right handlebar. And there's my force on it. So that's pretty simple to set up. So we do that for each of the handlebars and each of the pedals. Then finally the weight of the rider where the seat would be connected to the frame. We run a normal stress analysis. To do that, this takes about 5 minutes or so to run, maybe a little bit less. But to run the design scenario, it's going to run many different analyses using the sensors that we're going to show here in a second. But as you can see, we have our frame. It's showing our stress analyses. Might want to look at our factor of safety. And minimum factor of safety is 0.86. So that means we need to optimize something. We need to change materials, change frame design, or get a lighter rider. So we do that with the design study. Same thing, you set up a new design study. And we can even have the design study vary material parameters for us. So we can link the material properties and external loads as parameters as it shows on this slide. So currently the Poisson's ratio is 0.28, but we can change it to 0.33, 0.37, have it vary those parameters. change the yield strength, change the pedal force, the weights, the frame displacement. We wanted to optimize on that. And then we wanted to monitor the factor of safety. So if you look at the sensors that are in here, we can actually have it monitor the natural frequencies of the frame, the factor of safety, the maximum displacement, maybe displacement at a certain location. So you do that by adding a sensor. So I could say, go into my simulation data. Under my displacement, I can choose the resultant displacement in millimeters, maybe across all steps, or maybe at a specific plot step if it's a transient study. So that's how you would set up the sensor. So I've already run this one. It takes a little while to run here. Actually, did I save it? Maybe I didn't save it, and that's why I'm not seeing my results. Oh, here, yeah, the results are right here. Frame displacement, factor of safety. So if I want the one with the highest factor of safety, I might hone in on scenario 9, which shows a factor of safety of 8.51. But if I want to, I might want to look at other parameters here, so I can scroll up here. I might not, if I'm looking at the material that I'm using for that factor of safety, it's using a Poisson's ratio of 0.37. That might be too heavy a bike. So let's look at scenario 6, which has a Poisson's ratio of 0.28. That's also pretty close. So we're going to have a much lighter bike with a similar factor of safety with these parameters that we've run here. So we're just letting SOLIDWORKS crank out all the designs, no pun intended there.